Hi Anushka, I hope we are starting as per the schedule. Am I audible?
Hello, is my voice audible? Wait,
Yes, yes,
hello, am I audible?
yes.
Hello everyone, thank you so much for joining our webinar. We'll just begin shortly. Let's Hi, good evening everyone, and thank you so much for joining us today. On behalf of BM Infotrade, I'd like to welcome you all to our webinar on accelerating digital innovation through DevOps best practices. I'm Anushka Mathur and I'll be your host for today's session. We are really glad to have you here with us. Our today's topic is relevant because every organization under pressure is to innovate faster, release better products, and still maintain the reliability and security. DevOps has become a very crucial enabler in making this possible. And in today's session, we'll explore how businesses can use DevOps the right way to accelerate innovation. I'd like to introduce our speaker for today. I'm joined by Priyanshi Sharma and Lokesh Sharma and Gaurav Solanki, sir, who's a speaker. I'd like to Priyanshi to take over and start with the webinar.
Good afternoon, everyone. Thank you for being here. I'm Priyanshi Sharma, working as a DevOps engineer in BM Infotrade Private Limited. So, today I'm going to talk about a fundamental shift in how build and delivery software in past years. DevOps was seen as the people who manage servers. Today, the definition dead. Why? Because in 2026, DevOps is the backbone of digital innovation. DevOps is our risk migration strategy and our revenue accelerator. Today, I'm going to walk you through how we have moved from fragile legacy mindsets to adaptive engineering. So, let's start with the core problems. Architectural architectural fragility. Most systems are built to robust, but we all know that robust things are brittle. Think of a glass vase. It's a strong from outside, right? But if you drop it, it shatters in pieces. In software, fragility comes from synchronous frictions. This is when service A waits for service B, which is waiting for service C. If one tiny database query is the lagging in the backend, it creates a global thread exhaustion. Our entire site will going to be down, and it will throw 504 timeout error, not because you don't have enough CPU or RAM or any resources, but because your service are stuck waiting for each others. So the strategy, we have moved to adapt engineering. We decoupled boundaries using asynchronous messaging. We have achieved idempotency, means each request will going to be trace and there is no interdependencies between services. So we have built a system that knows how to handle failures gracefully through this adaptability. So let's look at a real IT example, a global payment gateway during a peak sale event. In a legacy synchronous setup, every transactions wait for a fraud detections or any bank APIs. If the bank's API lags by 5 seconds, for example, the entire checkout lines will going to be stopped. So the solution for this, we have implemented asynchronous decoupling. The user click pay and gets an instant processing notification while the heavy lifting up happens in the background via messaging queues. And this results as even with backend latency, the buy now button never stopped working and they have achieved 99.99% high availability because the front end was no longer held by backend bottlenecks. As leaders, we need a dashboard for excellence, right? We use DORA metrics that refers to DevOps research assessments. We focus on cycle time, the speed from commit to production, but speed without stability is a liability. This is why mean time to recovery is our north star. Elite teams don't avoid failures, they automate the recovery. When Amazon deploys every build in within 11.7 seconds, they are not being reckless. They are using automated guardrails to ensure that if a bug reaches production, it is rolled back before it impact to the bottom line. And the achievability, we have done this. We have used CI/CD for the same. So here the infrastructure immutable state management. Through this, we are ending the era of manual server handling, where engineers manually patch and nature individual machines, any patches, and any software installation were manually. So we have achieved. Yeah. So we are moving to disposable identical infrastructure. This is immutable infrastructure. If a server misbehave, we don't fix it. We terminate it and deploy a fresh image. This eliminates environment drift, the silent gap between staging and production that causes 60% of deployment failures. With declarative provisioning, if it's not in the code, it doesn't exist in our environment. So I have also mentioned one more case study over here where environment drift isn't just a technical depth, it's a financial outcome. It's a example of a Knight Capital Group company in 2012 have lost $440 billion in 45 minutes. Why? Because they manually update 7 servers but missed the eighth one. That single different server run old code that triggers a massive trading disaster. The lesson we have got from this case study is that manual intervention is a liability by enforcing immutable state. So how we can manage this? We can ensure that whether we have 10 servers or 10,000 servers, they all are 100% identical and audit ready at all times. So, in the next part, continuous security and compliance. Security is no longer a checkpoint at the end of the month or any production deployments. It is a continuous guardrail. We use self-healing mechanism, and we have used CEST or SCA scanning before code reaches to the production. We scans regularly container images where developer pushes every image to the GitHub or any source code management tool. It scans and uh, it scans the vulnerabilities, and it if it founds any vulnerability which is uh, associated to the code or images, it fails the pipeline and it shifts the images to the developers again, so they can check the vulnerabilities and they can rebuild the code or they can find the fixes. We are also embedding cluster benchmarkings to set up a secure cluster where we are deploying our applications. And for vulnerabilities we found while these scans, we are managing them in a centralized way.